Good morning, students. In this lecture, we are going to solve a problem in designing a sequential circuit. Right. Now, the problem is here design the sequential circuit specified by the state diagram, right, using JK flip-flop. Right. Now, here first you should know the JK flip-flop excitation table. Right. So, JK flip-flop excitation table. Here, JK flip-flop characteristics table is here. What is the J and K value? Then the corresponding what should be the value, right? Here characteristic table is J value, K value. So we are having now the flip flop with two input, J input and K input. Then we are having a clock. We are having a clock, right? Then output is Q and Q bar. Output is Q and Q bar, right? Now here if you are giving that value 0 0, then no change in value. No change in value. So this is the one storage, right? So here if you are applying 0 0, if already Q is 1, then you retain 1, right? If already Q is 0, only two state, Q is 0, then it will be retained in 0. So that is, if you are applying that value 0 0 and apply a clock pulse, then there is no change in Q and Q bar. So no change in value. So JK flip-flop, if you are giving input 0 0, then the result is no change. No change. No changes. Q is retained as it is, right? So that is Q. What is the Q and what is Q? Right. So current Q is retained as if you are applying clock, right? Next one is J0 K1. So another one. Right, so what's the value now? J0K, if you are set think that value K, definitely the Q is going to be 0. Q is going to be 0. So that is called reset. So we are having now the reset. Reset is the Q is 0 is reset, the Q bar is 1. Q is reset, the Q bar is 1, right? Next is here we are having now that JK flip-flop, then we are having applying the 1 0, the result is set. Set is Q1, whatever that value it may be, right? Q is 1, then Q bar is 0. So that is set. Then 1 1, then we are having complement. Complement means if the Q is 0, it will change as 1. If the Q is 1 already, it will change as 0. So this is the characteristic table of JK. So JK flip-flop characteristics, right? So directly you write it as a delete now here. So characteristic table of JK. So that is here you write the characteristic table. Characteristic table for JK flip-flop. JK flip-flop. Flip-flop. What is the characteristic table is? What is J? What is K? Then if you are giving the J and K, then what is the action, right? So what is the next value? So here we are having now 0 0, no change in value. No change in value. 0 1 reset. Reset, right? Then 1 0 is set. Right? Reset is Q is 0. Then set is Q is 1. Then 1 1 no here a complement of already existing, right? So if Q is 1, then it will change as Q equal to 0, right? If Q is already 0, it will changes as Q is 1. This is a complement. Here no changes. If Q is already 0, if you are applying, then there is no change in value. Q equal to 0. If Q is already 1, if you are applying that input, then input and clock, then it won't change Q1. So that is no change in value. Here reset is Q is going to be 0, right? Then set is Q is going to be 1. Then here complement is if it is 1, it will change as 0. If it is 0, it will change as 1, right? So this is the characteristic table. Now from the characters table, now we have to write the excitation table. What do you mean by the excitation table, right? So this is the characters table. Then from that one, you have to get the excitation table, right? So what it is actually Q of t and Q of t plus 1. If you want to change, what should be the j value and k value? So Q already 0, then is change to 0. 0 to 0 change. Then what should be the j value, right? So 0 to 0 change, what it is? 0 to 0. So no change is one possible. Then here we are having now 0 to 0, reset is possible. So these two cases. So here j should be definitely 0. Then k is 0 or 1 x. 0 x. 0. Here don't care. K may be either 0 or 1, then we are having a transition 0 to 0 itself. Next one is 0, 1. So another possibility, right? So you are having all possibility, you are writing 0, 0, 1, 1, 0, 1, 1. Now, here we are having 0 to 1 change. 0 to 1 change. One possibility is complement. 0 to 1 can be changed. Then here we are having the set. So these two. So these two, if you want, and then j should be 1 and k can be, don't care. So j should be 1, k can be, right? J should be 1, k can be anything x. Next, 1 to 0. So 1 to 0 is either this one or we are having the reset. This one and a reset. So k should be 1. So this or that. K should be 1 and j can be any value. So x 1. Then first 1 to 1. So that is here. This is 1, then 1 to 1. No change as well as this set, right? So here k should be 0, j should can be anything. So x 0, x 0. So this is the excitation table. This is a excitation table, right? The top one is characters table. This is excitation table, right? Now, see, here you just you memorize otherwise. Directly you can write the excitation table, right? Directly we can write excitation table first. So in that excitation table, you know, you should know that one 0x, then 1x, x1, x0, right? So here you have to write that 0, 0, 0, 1, 1, 0, 1, 1. Then here this is the possible input you have to give. Then you will get now the corresponding transition. Now using that one, then we are going to solve this problem, right? Now here we are having here we are having two flip-flops, A flip-flop and P flip-flop, because two value 0, 0. So we are having now A value, AB is the present state and X is the input, right? So here from this state here, this is case 0, 0. From 0, 0 to by input 0, it will transit to 0 itself. This is the one transition, right? So 0 itself. So here the transit is the next value of A and B. Next value of A and B is transit from 0, 0 to 0, 0. Right. Next we are having now 0, 0, 1. So you write all possibility now, right? So that is here 0, 0, 1. So for 0, 0, 1, we are having a transit to 0, 1. Transit to 0, 1. So this is a 0, 0, 0, 0, 1 to transit to 0, 0, 1, right? Then here you have to write that one as 0, 0, 0, 0, 0 to by input 1, it will go to 0, 1. Next, then this is another case 0, 1, 0. If you are having 0, 1, by input 0, it will go to 1, 0. It will go to 1, 0. This is the case, right? Then 0, 1, 1. 0, 1 by input 1, it will go to 0, 1 itself. So this is the case. 0, 1 itself. Right? So you put now that one as 0, 1. 0, 1. Then here we are having 1, 0, 0. So 1, 0, 0. This is 1, 0. 1, 0 by 0, it will go to 1, 0 itself. 1, 0. Then 1, 0, 1. The next value. 1, 0, 1. So 1, 0 by 1, it will go to 1, 1. 1, 0 by 1, 1, it will go to 1, 1. Then 1, 1, 0. So 1, 1, 0, 1, 1, 0, it will go to 1, 1 itself. Then 1, 1, 1. So 1, 1 by input, right? So this is the state 1, 1, 1. By input 1, it will go to 0, 0. So you write it here 0, 0. Right? Now, here you have to give the input value. We have to give the input value, right? So that is here you write the JAKA, then JP, KP. Right? So now you draw the line here. Okay, now here you have to write what should be the JAKA, right? Then what should be the JP, right? Then here 0 to 0. So A is 0 and the next state. This is a present state, right? So this is the next state. So A is from 0 to 0. So 0 to 0 is here 0 to 0. For 0 to 0, the J is 0, K is X. So 0 X. Similarly, here B is 0 to 0. Then this also 0 X. Next, A is 0 to 0. Then input is 0 X. Then B is 0 to 1. 0 to 1 is here 1x. 0 to 1 is 1x. 1x. Then here 0 to 1, this is 1x. Then 1 to 0, 1 to 0 is here x1. 1 to 0 is x1. So you write that one x1. x1. 1 to 0. Next 0 to 0, then 0x. Right? Then 1 to 1, 1 to 1 to 1 x0. 1 to 1 x0. Next 1 to 1 x0. 1 to 1 x0. 1 to 1 is x0. Then 0 to 0 0x. 0 to 0 0x. Then 1 to 1 1 to 1 is x0. Then 0 to 1 0 to 1 is 1x. 0 to 1 is 1x. 0 to 1 is 1x. Then here we are having now this one, right? So that is here 1 to 1. 1 to 1 is here x0. Then this also 1 to 1 x0. Right? Then here 1 to 0. 1 to 0 is x1. Right? Then this is 1 to 1. 1 to 0. This also 1 to 0 x1. right? So using the excitation table, you have to fill these values, right? Then here we are filling now, and then you have to draw Karnaugh map for all JK, right? So here you have to draw a Karnaugh map for all JK, right? So that is here we are having now. Right. Here we are having now that one as AB, this is X, then this is for JA. So 0, 0, 0, 1, 1, 1, 1, 0. So X is 0, 1, right? Now here you have to start from 0, right? So that is 0 location. This is 1 location. This is 2 location. This is 3 location. This is 4 location. This is 5 location. This is 6. This is 7, right? In that order, right? 0, 1, 2, 3, 4, 5, 6, 7, right? Then here you have to fill now 0. So this in that JA, right? So JA is now we are filling now 0, 0, 0, 0. Then 1, 0, 1, 0. Then 4 x's, right? So this is x, this is x, this is x, this is x, right? Now here you use as like a Karnaugh map, you have to find out any 4 combination or two combinations, right? So that is here is 2 combination you take now, x and this x you take it as one pair, so you take this one as one pair. So for that pair, what's the formula? Value formula is here B. So we are having now that B value, and then you put now that X is 0, right? So that is B. You take that B and you have to take now the X B value, and you have to take now this one as so JP, and here we are having now X bar. X is here is that 0. So JP X bar. So that this is the equation for JA input. Similarly, here you have to draw for JP. Zero, 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 1, 1, 1, 1, 0. Then X is 0, 1, right? So this is for KP. This is for KA, sorry, JKA. So for KA, now we are going to calculate now. So what is the calculation now, right? JA, this is actually we are giving Q as QP, right? So that is here we are having now this is this is QA, right? So that is here we will consider now, right? Next we are having now KA, right? So KA is this one. So initially 4x and triple 0 and 1, right? So x, x, x. So this is 0, this is 0, this is 0, this is 1, right? So that is the last one is 1, right? So this is 1, right? Now you take this pair. So for that pair, then we are having now that KA is equal to here, this is B, K equal to B, and this is X. So this is we are having now JPX. JPX. Right. Next, we are having now for JP. So JP, we are going to draw the table. Zero 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 1 1 1 1 0, then 0 1. AB, this is X. Right. Now JP, right? So that is here 0 1, this 0, and this is 1, then here XX, then we are having 0, this is 0, and this is 1, then here we are having now XX. Right? Now here we are having the combination is the 4 ones. We are having the combination. Right? So this is for JP. So JP equal to X because everything covered here, right? So AB is covered. So you no need to consider that AB variable. Then X is 1. So that is directly you put now X. JP equal to X. Then KP. 0 0 0 1 1 1 1 0. So this is we are having now X is 0 1, right? Now we are filling XX XX, then 1 0 1 0, then here we are having now XX XX, and then here we are having 0 1 0 1, right? Now you take that one as this one X and this one X, right? So this is we are having now Kp equal to, here we are having now that A bar A bar. So because of this 0 0, this is A, this is B. 0 means A bar. Then here we are having X bar, A bar, X bar. Then here we are having now, this is A, this is X, plus this is A, this is X, right? So here we are having now, this is actually equal to exclusive NOR of that AX, right? So that is here, if you are drawing that one exclusive NOR, right? Exclusive NOR of that AX, exclusive NOR of that this is A, this is X. You are getting now that one as A bar, X bar plus AX. This is the output for exclusive NOR, right? Exclusive NOR, right? So that one is here, right? This is you think about that one, right? So A bar, X bar plus AX, that is exclusive NOR, right? Exclusive R is AX bar plus A bar X. This is exclusive R. This is exclusive NOR, right? You see that. Escape. Okay. Now we are going to draw the diagram, right? So here we are going to draw the diagram for this case, right? I'll delete this one. Okay. Now we will draw the diagram now. JA. Okay. Next one JP. Right. So two flip flop. JK, right? So that is here we are having now that one input is one input. This is JA. So this is A. So this is a flip flop, A flip flop. This is A flip flop. A flip flop. This one is P flip flop. This is B flip flop. Okay. Okay. J P flip flop. Right. So this is we are having now J of A. This is K of A. This is J of B. This is K of B. This is the input. Then we are having now this is Q. Q is A output. Q. This is Q bar. This also Q. This is Q bar. Right. Then here we are having now the clock. If negative clock, then we are having a bulb here. Bubbles here, right? Then you have to connect with these two is connect with one clock pulse. CNK. Right. Now here, how do you do that one? JA equal to JP X bar. So one input is we are getting now that X. So here we are getting now, if this is a clock, then here one input as X input. Here we are having now one X input. Right. Now here we are having JP X bar. So JP is this one. JP. So you take that one as this B clock J, right? And then JP, and then here we are having X bar. So not JP X bar, you put and you put it that in J. So this is JA equal to JP X bar. JA equal to this is the JP, right? So output JP, and you take that one, and so you are getting now this one as JP X bar. So this is the input for this one, right? Next KA equal to JPX. JPX. That is KA, right? So this is you take that one here itself, right? Then here you have to take that this is X. So you take these two and put AND gate and you connect with X and JP. So this is JP and X. So this is the case JP and X. JP and X. Right? Next, here JP equal to X. This is JP. JP equal to X. So X is connected with JP. And then here we are having now A and X. A and X exclusive now, right? So that is you are taking now that A. A is this one, right? So you are taking that A and this X. You have to connect with exclusive NOR. You have to connect with exclusive NOR and to the key. So this exclusive NOR is here A bar X bar plus A X. So this is the case you have to take. So this is exclusive NOR. To draw the diagram, right? So this is the JK flip flop sequential circuit. So you should draw the clock as well as then you have to connect with a proper connection. That's all the JK flip-flop design for the sequential circuit using state diagram. Through the state diagram, then how do you design a JK flip-flop sequential circuit? We'll stop here. We'll continue by next